Okay, hello everyone. Hope you all are doing well. So in this video, we have to discuss vapor pressure and Raoult's law. Okay, so let's start. So vapor pressure. So what do you mean by vapor pressure? Vapor pressure means we know that at a constant temperature, the pressure is exerted by a vapor of a liquid on its surface when they are in equilibrium is called vapor pressures. Okay, and vapor pressures depends upon the factors. First one, nature of liquid, and second one, temperature. Okay, these factors affect vapor pressures. Okay, and vapor pressures will be studied in two systems. First one is liquid system. First one, liquid system, and second one, solid in liquid system. Solid in liquid system. So initially we have to discuss liquid system. So in liquid system, that means when a solution is called liquid, that means the solution is liquid when the solvent is liquid, but the solute may be solid, liquid and gases. Okay, we know that solution means solute plus solvent, right? So solvent must be liquid, but solute may be solid, liquid and gases. So that is called liquid solution. Okay, so in this, suppose in a container, so these are the liquid. So this is liquid phase, this is vapor phase, right? Okay, so the in a solution basically, okay, that is two components are present. That means in two components, so that is called what? Binary solution. Binary solution which present what? Two components. So in this case, two phases are here. One is vapor phase, one is liquid phase, right? So as the solution is binary, so in the binary solution, P1 is the, okay, or suppose we will take two liquids, liquid A and liquid B. Okay, we have to take two liquids. So PA is the partial pressure of what? Liquid A. Like that PB what? Partial pressure of what? Liquid B. Okay. Now Raoult's law. Come to Raoult's law. So what is Raoult's law? According to Raoult's law, the partial pressure of the each components in a solution of volatile liquids is directly proportional to the mole fraction of these components in that solution, right? So how will you express? So PA is the partial pressure of the liquid A is directly proportional to its mole fraction chi A. Okay, and like that PV is directly proportional to what? Chi B. Okay, so if you remove proportionality constant, what will happen? PA is equal to PA naught chi A, equation 1, and like that PB is equal to what? PB naught chi B, equation 2. So in this case, after removing proportionality, we get PA naught and PB naught. So what are these? PA naught and PB naught, basically they are called partial pressure of the liquids and B in pure state. Okay, P only represent for partial pressures when not designate. So these are represent for what? In pure state. Okay. So again, now, so both the components, the mole fraction of have always 1. Okay, the mole fraction of this two components is 1, implies chi A is equal to what? 1 minus chi B, right? Now again we know, according to Dalton's law of partial pressures, Dalton's law of partial pressure. So what is Dalton's law of partial pressure? So Dalton's law of partial pressure states that the total pressure in a solution of volatile liquids is directly proportional or equal to the partial pressure of the two components. Okay, that means in simple we can say that the total pressure of that solution in volatile liquid is equal to the sum of the partial pressure of the both the components in that solution. Okay, okay. That means P total or P solution, we can write out PS. So PS means P solution, pressure of that solution. Total pressure means what? Pressure of that solution. So is equal to what? PA plus PB, right? So this is equation 3. Now we have to put the values of PA and PB from equation 1 and 2. From equation 1 and 2. Okay. So what will happen? PA is what? PA naught chi A, PA naught into chi A plus PB equal what? PB naught chi B. ठीक है, clear? Now, so what is chi A? Chi is what? 1 minus chi B. This is equal to PA naught chi is equal to 1 minus chi B plus PB naught chi B is equal to PA naught plus chi B PB naught minus PA naught. Check it. PA naught अच्छा. So we have to first expand it. So we have to open this bracket. PA naught multiplication PA naught into 1 PA naught minus PA naught chi B plus PB naught chi B is equal to what? PA naught plus chi B into PB naught minus PA naught. Let's check. PA naught plus PB naught chi B, PB naught chi B plus ये माइनस PA naught into chi B, right, plus PA naught right. So this is the final statement of this Raoult's law. Clear? Okay. Okay. So so if you see the plot of this equation, okay, If you draw plot of this expression, vapor pressure versus mole fraction, this is PA naught, this is PB naught, this is mole fraction, this is vapor pressure. So PA naught is equal to PB naught, that means this is pressure of solution, that means total pressure equal to what? PA naught plus PB naught. So if you draw these dotted lines represent what? Partial pressure of this liquid A. From this point PA is equal to what? PA naught chi A, and this point represents PB is equal to PB naught chi B. Okay. Chi is equal to 0, chi B equal to 1, chi A 1, chi B 0, right? Okay. Because this plot express vapor pressure against mole fraction of these components in that particular solution. So this plot PA is equal to PB. Okay. So this is represents total pressure of that solution, which is combination of what? Partial pressure of pure state of these liquids A and B respectively. Okay. And these dotted lines represent what? Partial pressure of the liquids A and B. Sorry, this is not node, right? Clear? Okay. So let's start do some questions. The vapor pressure of chloroform and dichloromethane are 200 and 415 mm of Hg respectively, of Hg at 298 Kelvin respectively. Okay. Calculate vapor pressure of the solution which is prepared by mixing 25.5 gram chloroform with 40 gram dichloromethane at 298 Kelvin. Okay. So let's do the solution. So what is given in the questions? The vapor pressure of chloroform and dichloromethane are 200 and 415 mm of Hg at 298 Kelvin respectively. Calculate the vapor pressure of the solution prepared by mixing 25.5 gram chloroform with 40 gram dichloromethane at the same temperature, right? So we have to calculate first. We have to know the molar mass of these components. Two components are given in this solution, chloromethane and dichloromethane. Okay, trichlor and dichloromethane. So molar mass we need. After that we have to calculate number of moles and mole fraction. After that we have to put the final expression of the Raoult's law. Okay. So molar mass of CHCl3. So 1 carbon mass of 1 carbon 12 plus 1 plus 35.5 into 3. So 35 into 3. 106.5 plus 17, that means it is coming out 119.5. okay, and like that molar mass of what? Dichloromethane, it is coming out 12 plus 2 14 14 14 71 85 gram. ठीक है, so you get the molar mass. Right now number of moles of number of moles means what is the formula? Given mass upon molar mass. Given mass of chloroform is 25.5 divided by molar mass is what? 119.5. so it is coming out what? 5 so it is coming out 0.213 moles. 0.213 moles. Like that number of moles of dichloromethane, what is the given mass? 40 upon 85, so it is coming 0.85 4 okay, 0.47 moles. Now what is the total number of moles? Total number of moles is equal to what? So 0.47 we have to add, okay, 0.213 plus 0.47 यानी कि 0.213 0.47 3860, so it is equal to 0.683 moles, right? So we get the total number of moles of this components, right? Right now we have to calculate number of fractions, okay, so mole fraction. So let's start. So we have to note down, okay, because I have no space, so I will continuously erase, okay. So again that, so total number of moles we get 0.683, right? Now mole fraction of what? Chloroform. So for no mole fraction of a particular component, so we need number of moles of that component divided by number of moles of all components. So number of moles of chloroform, what we get? 0.213, and for dichloromethane 0.47, right? So 0.213 divided by 0.683, it is coming out 0.312, right? And like that mole fraction of dichloromethane, okay, so what is the number of moles of dichloromethane? 0.47 upon 0.683, it is coming out so it is coming out what? Okay, so it is coming out what? 0.688, okay. So now we get number of moles, total number of moles, and mole fraction, okay. Now by using Raoult's law, that means the equation is what? Total pressure or PS is equal to what? P1 naught plus P2 naught minus P1 naught into chi 2. Okay, so this is equal to what? P1 naught means what is the vapor pressure of the chloroform? 200 plus P2 means of dichloromethane 415 divide again minus 200 into J2 means or total J mole fraction J2 dichloromethane. This is for dichloromethane 0.688, right? So we get 200 plus 415 minus 200, it is coming out 147.9 is equal to 347.9 mm of Hg. Okay, so this is the answer 347.9 mm Hg. You get the answer, right? This is the final answer. We are calculating vapor pressure of the solution. So P total, that means pressure of that solution is equal to 347.9 mm Hg. Okay, so let's do one more question. Question number 2. Okay, so this is for task. Okay, I will not solve these questions because it will take lots of time. Okay, so the video must be in minimum time, right? So methanol and ethanol for an ideal solution by mixing 23 okay okay by mixing 23 gram methanol with 32 gram ethanol in they prepare a solution, right, to form ideal solution by mixing this. Okay, and P naught methanol is equal to 90 mm Hg and ethanol P naught is equal to what? 51 mm of Hg respectively. Calculate the partial pressure of the solution. Okay, calculate the partial pressure of the solution so partial pressure of constituent, okay, of constituents partial vapor pressure, right? Constituents and total pressure of solution. And next asking, calculate mole fraction of each components in that solution. Clear? So everyone try. Okay, so hopefully you will do the solution, otherwise you can ask me in comment. Okay, thank you very much.